Good afternoon, everyone. Hey, get up and stretch, right? Let's get energized. We're going into the home stretch. Thank you for joining us for commercial heat pump water heating systems, the water heating solution in a building electrification. And our speaker is Thomasena Philen, who is a senior manager of training and content at DNR International. I first met Thomasena a number of years ago at the HVAC Excellence Conference in Vegas, sponsored by the ESCO Group. And I was very impressed by her technical savvy. As I've learned, she is in fact a community college graduate. She earned her AS in residential HVAC at Eastfield Community College. And, she's been involved in this trade ever since. So with that, Thomasena, you have the floor.
Thank you, Larry. Hi. As Larry said, my name's Thomasena Philen. I'm the Senior Manager of Training and Content for the Learn team at DNR International. I'm going to go ahead and share my screen. If I can share the right screen, that would be best. And get started. So my assumption is that you can see the front page of the presentation. Very nice.
Yes.
Very nice. So given that we only have about 20 minutes, I'm going to jump right through on a couple of these and start just talking about commercial heat pump water heaters and how they fit in the whole picture of decarbonization, electrification of the built environment. And let's take a look right here at this one graph. And there's a lot going on in this graph here, but the things that are most important right now are first the timeline. We started recording in 1990, and we're projected out to 2050. And these are the greenhouse gas emissions, and this is targeted to California in this situation. And what's most important here are the three blue sections, because that's the built environment. The others are the agricultural and transportation. And you'll notice that we peaked right here about 2005 in our greenhouse gas emissions, and because of the efforts in California, they've been gradually easing off. But it's not enough to get where we want to go, given that by 2050, we want to be 80% below the 1990 levels, which was right about right here. Now, as far as gas emissions, energy consumption of a given population, what you see here is 13% is common air conditioning, that's residential, small buildings. Plugs and light loads is 25%. And then you've got multifamily, which is a huge chunk for air conditioning, which is 12%, plugs and lights 25%. But then this 25% right here is water heating, domestic water heating, whether it's gas or electric. It's going to be an energy consumption in domestic water heating. And that's 25% of a given population. Now, if we were to take out an electric resistive load for the water heating and install a heat pump system, then you're cutting that consumption by 17% of the overall consumption of the population. And that's 2/3 of a savings, or you're cutting it by 2/3. Now, the other thing about heat pump water heaters is that they can respond to demand response events. And what that also means is that when the consumption is high and the grid starts to become unstable, the heat pump water heating system shuts down, and you can ride through these demand response events with ease because you've got a lot of storage in those water tanks. Now, we know about heat pumps. Heat pumps have been around a long time. Even heat pump water heaters have been around since the 50s. They started being installed in commercial kitchens because of their innate ability to cool the room while heating water. So it's not a brand new technology, but it is a technology that is being dusted off and reapplied here because inverter technology is a thing now. Improved coil sizes and function is a recent addition. And so what we have here is your inverter mini split heat pump. And those have been around for quite a while too, so they're not new to us. We've got here also a residential heat pump water heater. And if you look at this picture, you will see that it looks a little bit different, but not a lot different than a standard water heater that you'd see in somebody's home. The biggest glaring difference is going to be the ductwork that's attached to the water heater, because this is a heat pump and it does have to have air, fresh air, and to exchange heat with the space. Now, if we move over to the commercial side, these guys are actually really unique in that they are the Mitsubishi City Multi, and they're on the Skokomis Tribal Community Center. And they are not only supplying climate control for that building, but they are also supplying domestic hot water for the commercial kitchen that's in that building as well. And so this is more of a hybrid system that worked really well, achieved the targeted savings in energy consumption for that building, which was great. But over here, you've got pure commercial heat pump water heating. And so we've got the heat pumps here. They're quite large. We have our storage tanks here as well. Now, if you wanted to get into the nuts and bolts difference between what's considered a residential heat pump water heater and what's considered a commercial heat pump water heater, and there's a lot of wiggle room in the middle too for those things, in that residential is considered upwards of 120 gallons. Now, if I'm going to serve more than 4 dwelling units, that goes into the commercial category. If I'm going to be having 6 kilowatts or more of input power, that also goes into the commercial category, as well as anything over 120 gallons of water storage. Now, back to our little residential unit, we know that you've got the heat pump, typically, but not always, sitting on top. And then you've got your storage tank. You've got a resistive heating element here just to serve as a backup if needed. And then we've got our heat exchanger lining both sides of this storage tank. The same goes for a commercial heat pump water heating system, except for a matter of scale. So here is our heat pump. And then we have our primary water storage. So this supplies the hot water to the building. We also have our temperature maintenance system, and we'll get a little more into temperature maintenance and why that's important in a commercial setting, especially in multifamily. And then we have our controls. Now, it's also important to note that most, but not all, heat pump water heaters on a residential scale do have controls that are capable of communicating with an app on your phone or your tablet. And they also will typically have a CTA 2045 communication port, and it will be grid connected, so it can also respond to demand response events. The same goes for the commercial controls. These are typically off-the-shelf modules for the controls, or components for the controls, and not only are they interconnected with the building management system through a BACnet LawnWorks, but they are also connected to the grid through that EcoPort that I spoke of earlier. So if we want to take a look here, and we're going to walk through this building here at the very end of the presentation. So I'm going to pop on to the next thing, because it's a big deal when a building owner or a developer or even a design professional is trying to decide whether or not I'm going to go with what I know, which is a boiler, or what is new and energy efficient, which is going to be a heat pump water heating system. And so one of the things that's important to know up front is federal, state, local policies and codes are requiring clean and efficient electric technologies. It's a big push on the West Coast, and it's also a really big push in the Northeast, and some places dotted throughout the US where they're decarbonizing and electrifying and banning gas appliances. So, but boilers burn fossil fuels to generate the heat. But heat pump water heaters move heat from one source to the other, just like any heat pump would. It's moving heat from the air and putting it into the water. And that's not the only type of heat pump water heater that's available, but I only have 20 minutes. So the benefit of going with the boiler is that it's very common commercial settings with widely understood design parameters. And so engineers, developers, they know what they're getting when they decide to go with a boiler. However, with the heat pump water heating system, design has been an issue coming up through the last 10 years, and figuring out the best size, the best capacity based on load, usage, climate, entering water temperature, the whole bit. And so this has been a big learning curve, but it does require challenging the status quo and rethinking the design in applications. Because the heat pump itself doesn't really have that large a footprint. It's about the size of a refrigerator, most of them, but the water storage is significant. And so that has to be planned for, whether it's going to be in a retrofit or a new construction situation. These guys should not be cycling more than about 6 times an hour. So adequate storage must be considered and allocated. But because of the REACH codes and the decarbonization and electrification efforts, given that a boiler typically lasts about 25 years, it's a common lifespan for a boiler, as the same goes for the heat pumps as well, the building owner could end up with a stranded asset by 2030 or even sooner. And so they would get about half the life out of that boiler before they were forced to switch anyway. And so that's something else to consider right now when talking about putting in some sort of domestic water heating system, is what does the future of this building look like versus my investment into this building. And so that's pretty important too. Then we have a proven performance, it's climate friendly, and it's very energy efficient with these heat pump water heating systems. Now, we talked just briefly about footprint, and that is important in that this is a parking garage at the Jackson Apartments up in Portland, and it takes up about 4 parking spaces in that parking garage. And so given that this was a new building, architecturally, they were able to plan for that and build around this machine room for the heat pump water heating system. But not every apartment complex or not every building is going to be new, and not all of them have that much space to put in that kind of system. This is a distributed cluster. These are small inverter-driven CO2 heat pumps, and they are up on the roof, and they are connected to a storage tank just below in the machine room for that floor. Each one of these units serves 3 to 4 dwellings, best word for that. And so there are a total of 13 units on top of this roof at Hopeworks Station, and they serve the hot water needs for the entire 56 units that are there in the building. And then we go back to the residential heat pump water heater. And there are some considerations. They can go back in a like-for-like replacement for gas and electric, same space, but you must consider the airflow, and you also need to consider the condensate because heat pumps condensate, whereas normal water heaters don't. So that's another consideration that has to be thought about when doing an installation on a heat pump water heater. Now, the neat thing is that not all buildings have the space to put that kind of storage, and not all buildings have the ability to retrofit into a heat pump water heating system seamlessly. So what the industry is doing is moving to a more modular, off-the-shelf type system. Now, these guys are the Sanco CO2 inverter-driven heat pumps, and they can be manifolded together to achieve whatever capacity is needed. They can be put on the skid. You have your storage tank, you've got your temperature maintenance tank, and you've got all your piping right there, all built into the skid. It can get shipped to the site and then craned to the roof or to the ground somewhere near the building, wherever it's going to be served. And you can have your heat pump water heating basically plug and play. And so manufacturers and developers and engineers, design engineers are putting these together in a variety of sizes and capacities and shapes based on the load shape of the building, the use, and the design temperature of the location and the climate. And so these guys get shipped. They get craned up to where they need to be. They get connected to the building. They get connected to the electrical and then the controls, and then the system is commissioned. What that does is it saves a lot of money on installation, because when we go to look at the Jackson apartment parking garage in the tour here in just a few minutes, you'll see that a site-built system that was brought in component by component, part by part, fitting by fitting is a very expensive proposition for an installation, whereas these skid mounted systems are vastly reducing costs for the installation of heat pump water heaters. So some of what we've learned is that customized systems built from the ground up can be cost prohibitive, and it's very, very tempting if you're unfamiliar with the technology to oversize, which drives the cost of the job up because the extra expense of the larger equipment, and then it puts it out of the reach of the building developer. So we've gone to, as an industry, modularizing these systems whenever possible to meet the needs of most buildings. There's always going to be a need for a ground up build in some buildings. It just depends on the situation. And these plug and play systems for a variety of applications are already being manufactured by multiple manufacturers. So that is a big help to move the industry forward. One of the other things that has come up is in densely populated urban municipalities, New York, things like that. You may not be able to get crane in there to lift that system up there to the top of a roof. And so these components need to be small enough to fit inside an elevator and be elevated to wherever they need to be, either floor by floor or to the rooftop. And so right now, the industry, the national labs, several design engineers are working to develop and optimize more compact solutions to serve these high-rise buildings. And research is ongoing with test cases currently being monitored with some prototypes. The guidance for water heating was overly conservative initially, and hot water usage, it could result in over or undersizing, and either one of those is unfavorable when you're installing a new tech. You're adopting a brand new technology to begin with, and you're installing it. You have these high expectations that it's going to perform as desired, and then it has issues. And so the industry has updated hot water load shapes for major commercial building types. More and more are in study right now so that we can continue to feeding that data into the tool, which is the EcoSizer currently available to inform installations on a variety of building types. And the big one, and this is one that's really important to us, is that there's been very little training available on heat pump water heating, commercial heat pump water heating, and residential heat pump water heating, on the installation best practices, design best practices, just plain applications. And so over the last 3 years, a great deal of design and application training has been developed and is available, but the challenge now is how to forge channels for dissemination, whether it's a train the trainer situation or whether it's online on demand, consumable time of need. All of this is work. We are working to push this out through channels. But then we have the trades, and the trades are really the key, because if you don't have plumbers and HVAC technicians who are familiar with the technology, they're not going to be willing to step into that job and do the installation. And so system installation, operations, maintenance, and troubleshooting training for technicians is currently under development as well. And you can't underestimate, and I know a lot of this has been covered in this conference, how important it is for the building operator to understand the system operation and be able to maintain that system in-house. And so that type of training is also underway and being developed. And I'd like to take you, and this is the fun part of the whole tour, is this Jackson Apartments. If you have a mobile device and you wish to, go ahead and snap this QR code. I will find that with mobile devices or with phones, it's tiny. And so you may want to wait and use this. This will be available from the BEST website. Work on it on your own time. It's a neat thing though, because what you do when you click the link or follow the QR code is you're going to go to this site. And this site here has 3 different options. You can learn about the building and the people it serves and the area it serves, the climate, things like that. You can learn about the system. And after you learn about the system, you can also learn about the plans, that the basic design of the system. And so let's take a quick peek at the system itself. And this will take us to the parking garage of the Jackson Apartments. Like I said before, there are 156 dwelling units in this apartment complex. This room takes up 4 parking spaces in the underground parking garage. And so the question comes up sometimes, so why do you have it in a parking garage? And the primary reason is air buffering. It does get kind of cold up in there. And these units here, this particular brand, is not designed to go in the outside. It doesn't need to be indoors with you, but it does need to be sheltered. And the air does need to be buffered somewhat because it's a 134A system, and it will not continue to heat water below about 32 degrees. And so this particular type of unit is in the parking garage. This is the heat pump. If we went to the left here, you'll see that there is a temperature maintenance tank. And I'd like to spend a moment or two just to discuss temperature maintenance, because in apartment multifamily systems, multi-floor multifamily systems, they have to have a recirculating pump. So that pump is circulating water throughout the building. Now, once that water goes all the way up to the top and then all the way back down, it could have lost about 20 degrees of heat in that water. So this tank is dedicated to just topping off the temperature of the water that's recirculated in the building. And so when you're noodling around with this on your phone or tablet later, notice that anywhere there's one of these white arrows, that's a video. You hover over that, it'll tell you what it is. And then if you click the eye, it tells you more about the system, its COP, and its performance. And so as we walk through the building some more, you'll also see that this is really very important because these are huge storage tanks. These tanks are 500 gallons apiece, and there's 3 of them. And water can sit in these tanks for a significant amount of time. These heat pumps maintain the temperature in these tanks at 140 degrees, which is too hot to come out of the tap. That means that you need to mix, as the technician, the design engineer, you need to mix cold water with the hot water at 140 degrees to where it comes out of the tap at a safe 120 or maybe a little bit less. And so these temperature mixing valves are here to do that job. If we were to take a look at the storage tanks, you will also notice that they are heavily insulated. And the reason for that is manyfold. And the first one is that you don't want the heat loss in the pipes or through the tanks. Even though they come insulated, additional insulation has been added. The other thing is I've got a heat pump here and it has its own COP, but what really matters when you're dealing with a system like this is the system COP, because we have so many multiple components on a single system. We want to maximize and optimize every aspect of the system itself. And so there we have very heavily insulated piping throughout these 3 tanks are in a series, they are connected. And there's a lot of information available out there about tank stratification and recirculation and how important it is to have a temperature maintenance or a swing tank involved. Even training out there about the expansion tanks that's available now. But this is the tour, and there will be a link for it in the PDF that I'll be making available to Larry after this presentation. And I think now would be a good time to open up to see if there are any questions. And I actually have no idea how I am on time.
You're okay on time. You know, I paid Eugene to, you know, basically take a back seat. So there you go. Right. Okay. Okay. We've got a few questions here for sure. Let's see. I know that, yes, there was one about, again, you know, these units performing in colder northern climates, right? Especially, you know, relying on an air source for heat pump water heating, right? Can you talk a bit about that?
Sure. So on these larger 134A systems, they do have to be in a parking garage or someplace that buffers air. However, there are systems. The Mitsubishi Heat 2.0 is a CO2 system, and it's inverter driven, and the Senko with the smaller modular systems that I showed on the slide are CO2 systems, and they operate at downwards of -20 efficiently in the heat pump water heating sphere.
Wow, -20. That's
It's pretty
impressive.
cold.
Yeah, I'll say. Let's see, this next one, right? Let's see, in a hospitality setting, several heat pump water heaters can be combined with, say, a natural gas water heater to support the rapid first hour recovery issue. Controls could be difficult, however, right? What are you seeing with that kind of hybrid arrangement?
There are hybrid arrangements where you can combine the natural gas either as a backup or for that emergency recovery when you have massive hot water use and you need to heat up very, very quickly. But the flip side to that is if it's designed in a way to where your storage is large enough to handle that type of surge, then during the downtime, the heat pump can recover and recharge the tank. And controls, I mean, we've been in this industry a long time. We know that anything can be controlled. It's just how complex you want to layer those controls onto your system. And so it's going to come back to design and an in-depth knowledge of your water heating needs and uses. And so that all has to be taken into account when designing a system. There are hybrid gas and heat pump systems out there. It's just not the for multifamily and settings like that, where you don't have that instant recovery need, then that's typically not needed. But I can definitely see in a commercial kitchen where that might be helpful.
Mhm. Now, Ted asked a question that is related to that very first question. What type of supply air temperature range do these units generally have to work and maintain a high COP?
Well, as an example, and I don't work for a manufacturer, so it's going to vary based on manufacturer and brand and refrigerant. And so as the new A2L refrigerants are coming out, then the manufacturers are retooling and machining up whatever the A2L equipment, and they're already sending that type of equipment out too. This is going to change, but I know there is a big, big push to go to CO2, which means your entering air temperature could be a range of -20 to 120 in order to function efficiently. Obviously, the colder you get, the COP is going to drop off some, but ultimately, and when it's really, really cold outside, getting that hot water when needed, time of need, is what's most important. And then as it warms up, shoulder seasons and through the summer, you have massive efficiency gains in those situations. And so not every manufacturer currently has a CO2 system. But more and more are coming to the market. We have a process called, it's a process for approval to where manufacturers can get on the list of the DOE list of approved heat pump equipment. And more manufacturers are sending their products through that approval process to get on the list. And some of them do operate in quite cold temperatures. I know it's probably a little vague, but I can't speak to a specific brand because I don't work for a manufacturer.
Well, on that note, thank you so much, Thomasena. I really appreciated the digital twin of the Jackson apartment mechanical room. I think is just such a wonderful integration of both the virtual technologies along with more detailed information. I would just like to mention also, for those of you interested in seeing more digital twins, please check out the campus building, which you'll find in the South Seattle College booth in our expo hall. They did something similar with one of their campus buildings to create a campus's living lab environment. All right. And well, last but not least.
Thank you so much.
Thank you. Yes.